Okay, so I thought that the issue originally was going to be in sound init from csound.c, and in particular this CDDA start pause and end pause. Let me see if is the definition up here. Yeah, so these only support, so there is a limit, but it's 50 tracks, right? So it shouldn't fail at 40, right? Um, so the thing is, the error message, I don't know if I can get it to pop here. Let me see. Yeah, so the error message, the instruction at 417 BBA, uh, reference memory at 4BC 6C8. So I don't know what 4BC 6C8, but 417 BBA, it's this line, right? 417 BBA. And so this is actually a function called sound memory in mem manager. And so if I can get that up here, so get sound memory. The thing is, the addresses from the decompilation don't line up with this, but I also have the decompilation. So let's see, get sound memory. So it's somewhere in here. And so that line, D word pointer, EDX, EAX, that's what's failing, right? So that's in the decompilation. Where's get sound memory? Get sound memory. That's this line, so it's 2542, right? And so in the decompilation, that's this. So whatever this is failing. So I don't know. Like, I have no idea what the heck old top is. I have have no idea what P top of sound heap is. Um, let's see. Do the comments here show top pointer for sound heap, old top. Sorry, old top. Yeah, I'm not sure. It's. I think that's it, right? Does it? It's like one of these super esoteric things. It's something to do with sound memory. Like, is it that this doesn't have enough space? Like, I'm not. That's the other thing. Is like, I'm not a C expert either. And I usually am a developer on languages that use managed memory. So this is going against me. Let me see if Grok might have any insight. This line of code is failing. The application is saying the memory could not be written. This only happens if there are more than 40 50 Right access violation caused by memory corruption from a buffer overflow early in the initialization process. This overflow happens specifically when num.da tracks exceeds approximately 40. So actually I had 44 tracks, right? Understanding the crash site, the failing line. Let me also make this bigger so it's easier to read. And let me expand it. So the failing line, this is inside get sound memory. P top of sound heap is a global pointer that tracks the current top of the sound heap. The line is writing a sentinel value to the top of the new heap after bumping forward. This acts as a basic list node. Memory could not be written. Error means contains invalid address, unallocated memory, or a read-only page. It only fails if this has been corrupted beforehand. The corruption starts in sound init after detecting num.da tracks game loots. Fetch start end sector positions for each track. Fixed size arrays of 50D words. 200 bytes per total array. If num.da tracks greater than 50, so overflows into show. Overflow doesn't corrupt p-top of sound heap until a specific index. Offset from CA-DA start position is 172 bytes. Index equals 43. So then when I equals 43, Redbook track info writes to 43, which is exactly 8E3A8, overwriting p-top of sound heap with garbage. Okay, so this is perfect. If that's what it is, 43. Now I know there's weirdness with the soundtracks as well, because it's like it adds 2 to the value, so I don't know if that means 43 is actually when there's 41 tracks, or if it's actually like 43. Because the number of num.da tracks was coming out as 43 actually for me, even though I had 44 tracks. Which makes sense, right? Because the first track is a data track, so there's only actually 43 digital audio tracks, which is what this variable is, right? So 43 would be overwriting it. The overflow starts earlier. So I don't know, sometimes, I don't know if this guy is, okay, so it's hitting nearby variables as well. Okay, so CD track. That's the other thing. This AI, sometimes it hallucinates, so who knows? But I think it's onto something here. Num.da tracks is total tracks. Audio starts track 2. So data segment layout. This is what they infer, I guess, how the memory is laid out. And so the thing is, this isn't exactly how it is laid out in memory. It's like slightly, or at least the addresses are different, right? So these are the offsets, but the addresses in actual memory are going to be different. And I think, so for example, that 4BC 6C8 is where this is, right? So that probably aligns to this memory address. So the diff between, so let me see. I can calculate this to see if this is true. So 8E3A4 minus 8E39C. It's 8 bytes. So it should be, 8 bytes before 4BC 6C8. 4BC 6C8. I mean, that's just, yeah, 4BC 6C0. So if I go into Wacom Debugger and I check the memory, I just go up 1, 4BC 6C0, C9. That's not what I'm expecting, because I would be expecting 43. I'd be expecting the value to be somewhere up here if that was correct. Do I even see a 2B anywhere? Let me see this again. 4BC 6C8. Huh. I mean, those memory addresses could be wrong, or the AI is hallucinating the position of numDA tracks, right? Because it's only looking at 2 C files, so it might be thinking that those are the only 2 C files in the code, and there's probably more. You know what? I have numDA tracks here. Can I actually see where this is in? Yeah, I can. Okay, yeah, this is a completely different location. That's 5C, 2FO. Okay, so it's wrong on that part, that numDA track. So I don't know if this is right then, right? I don't know if it's right that this array is overwriting that. You know what I can do, actually, is I can check this and see where the raw memory. Yeah, no, so that's not right. I mean, so there's definitely something. There's something with this line that's failing. At least that's what it seems like, right? To confirm this, what I need to do is do a debug point. Debug right there. Let me make sure. I don't know if there's an easy way for me to check all of my breakpoints, because I actually want to disable the other breakpoints if possible. View all. Right, so disable. Okay, so I only have one breakpoint now, so I think I need to reopen this. Okay, and then go. Okay, so there's no error message. I broke before that line. Right, no error message. No error message. So that's interesting. When that line, why does the music start playing? what the heck? So C sound, this is what I don't get. So start DA track. This is what starts playing the music track, right? Is start DA track. So let's see what the execution order is. Right? I don't get that. Okay, so let me restart this again. So let's get rid of this MK Trilogy. I don't know if it'll let me just kill it or just reopen it then. Okay, there we go. Okay. I think that's good. View all. I got my breakpoints. Sound. Start DA track. Okay. Okay. So now when I run it, what's the first debug point I hit? Okay, where are you? Is this the debug point? Is C sound? So it's starting DA track first. Oh, interesting. So win main is interesting. Okay, so I need a debug point here. So let's see the functions on win main, or is it just... Okay, you know what? I need to open the application again. Okay. So this is like the start of the application, right? But yeah, okay, so start DA track is right there. So let's debug. Okay, so this is like saying initialize the memory manager, start up sound. Interesting. Okay, so let me get rid of that debug point on start DA track. I don't need that one. Okay, I don't know what the heck that is. Let's get rid of that one. Okay. So now let's start and see where we are. Okay. So no errors so far, right? So load common sounds, no errors. Part of load common sounds now is getting sound memory. And that's where this failure is. What I don't understand is why the music starts playing when that happens. That might just be a weird quirk of the debugger, like, because I think the music should start playing before then, right? I don't understand that. That's why this gets down when you start the music. That's weird. I don't know. Okay, I think what it is the debugger ends. The debugger stops, right? Because of this application error. That's the error, right? It's get sound memory. So again, I think in isolation it's hard to understand why. Right? There's something else which is causing this to fail. But this is literally the start execution of the game, right? It's really close to the start of the execution of the game, so not much is happening, right? It's initialize memory manager. There must be initialize sound here somewhere too, right? Startup sound. Startup sound. This is in W sound. So I've not reverse engineered W sound. Let's see what's in W sound dot C. Do I, is that, it's not showing up in this. I wonder why. What functions are in here? Startup underscore sound. Startup underscore sound. Okay, it's just part of, it's called sound.c in the source code. It's sound.c. Okay. Let me ask Grok to reverse engineer this guy. Let me see. While it does that, let's go back to W main. See what else. Okay, so detect true color. Command line. So there's some command line switches this thing supports. Reset tool. So literally it's just init memory manager, startup sound, start DA track. Wow. So does it even, let me see what startup sound calls. Init driver. Like, I'm wondering, does init sound get called even? So let's go back to C sound. Sound init, right? Does start DA track call sound init? Doesn't. What calls sound init? Right? That's important. It gets called, right? Let me see here. Sound init. Something calls sound init, right? What calls sound init? Okay, so sound C does call it, right? Okay, so startup sound. Okay, so I just didn't see it. Okay, good. So that makes sense. So startup sound happens. So let's go back to win main. So this is starting, or W main, sorry. Um, Starting to make sense. So this is the startup procedures, right? So there's init mem manager, startup sound, start DA track, and load common sounds calls the sound memory thing, I think. Is that what happens? We're starting to get into memory. Yeah, it calls get memory. Does it call get sound memory? Oh, interesting. Try main. Trilogy main? Interesting. Free sound memory. Is there a load sound? Sound. It's got to be somewhere in here. Let's see. Let's go back to mem manager. It's the function get sound memory. What calls get sound memory? Who are you? So init sound bank, which I did see somewhere there, right? Who calls init sound bank? Trilogy main calls init sound bank several times. But let's see, which one do I think it is? Oh, yeah, the search is like a little unaligned. So there's this process background. Load fighter sounds. It's probably load fighter sounds or load common sounds. Yeah, it's probably this one, right? Load common sounds. And what calls load common sounds? Load all fighters. Okay. Okay, and let's just see grok. Which one was this? This was sound.c. Okay. So let me do this. I need to save this here. Sound.c. Yeah, so it's this line that's failing. Why? I don't know. Um, Something's going out of bounds somewhere. I don't know. Okay, that's all I got for now.